In this video, we're going to talk about linear inequalities in two variables. Below are some definitions that are listed. What I want to draw your attention to is how you graph a linear inequality. First, you want to put your linear inequality in slope-intercept form. You want to then find your slope and your y-intercept, graph this line, and then you're going to look at your inequality. If it's equal, it's going to be a solid line. If it has no equal, it'll be dotted line. And then in order to figure out what to shade, pick a point on either the top or bottom or some sort of point that is not on the line. I usually use 0, 0. First example, we want to be checking solutions of inequalities. What we're going to do is we're going to focus on this equation here. We're going to be plugging in our x and our y. So we have negative x, which is 0, plus 2 times our y, which is negative 6, is less than 6. 0, 0, so we can take that out. 2 times negative 6 is negative 12. It's less than 6, so this is a solution. Next, we want to do 2 and 4. So we have negative 2 plus 2. Our y is 4, which is less than 6. So we have negative 2 plus 2 times 4 is 8. It's less than 6, so we have 6. It's less than 6. Not a solution. Our next equation, we have negative 3 is 2, and 2 is y. So we have negative 3 for negative x, so we have 3 plus 2, or y is 2, is less than 6. So we have 3 plus 2 times 2 is 4, it's less than 6, so 7 is less than 6, so that means that this is not a solution. In our next example, we're going to be graphing two linear inequalities. Our first one's going to be 2y plus 6. Then our next one will be x is greater than or equal to negative 5. So our first one, 2y is greater than 6. Divide by 2, so y is greater than 3. Let's just go ahead and do our other one too right now. So we have x is greater than or equal to negative 5, and that it's already solved. So what we want to do is we have y is greater than 3. So we're going to find our 3, which is here. Now, earlier we talked about if it has an equal sign, it's solid. If not, it's dashed. It is not equal, so it will be dashed. And y is just 3, so dashing our line here. Now the question is, where do we graph it? Earlier I said we're going to plug in 0 for our check. So we like to plug in 0, 0. So does this point 0, 0 work into it? 0 for y is not greater than 3. Therefore, we'll shade above. So that is the first problem. If we look at our next one, if x is negative 5, so 1, 2, 3, 4, 5. Is it equal? So it's solid. And I like to use 0, 0. 0, 0 is here. Is it included or not? 0 for x is greater than or equal to negative 5. So yes, it is included. So we shade that right. So those are all possible answers. In this example, we're going to be graphing linear inequalities in two variables. So we're going to look at our formula y is greater than 2x minus 5. We always want to graph lines in y equals mx plus b, where m equals your slope, b equals your y-intercept. So our slope is 2, our y-intercept is negative 5. So I'm going to find -5 because it's where it crosses. It's y-intercept 1, 2, 3, 4, 5. Our slope is 2, so I'm going to go 2, 1, 2, go over 1. Go 2, go over 1. I'm just going to draw on the equation. Now, is it solid or not solid? Well, our equation is no equal sign, so that means it is a dotted line. And now we decide, do I shade to the right or do I shade to the left? So we're going to plug in 0, 0. So 0 is greater than 2 times 0 is 5. So we have 0 greater than -5. Is that true? Yes, it's true. We shaded it in. That is it for today's video. Thank you for watching. Let me know if you have any questions. Thanks. Bye-bye.